Welcome back to International Innovations. This is the second part conversation on biofuels, and we'll pick it up in the conversation with Sylvain, Surajit, and Bob. What a great conversation we're having. We talked about the feedstocks and related to biofuels. Could we talk now a little bit about the generations of biofuels? And really, let's talk about today's global marketplace when it comes to biofuels.
I can start maybe, and then the rest of the team can elaborate. So let's look at feedstocks. So there's not an official definition what is first, second, third generation. So I will use the one we use in terms of. So first generations, which we refer to a lot, is vegetable oil. So rapeseed oil or canola, as it's called sometimes in North America, sunflower, palm oil, soybean oil. So those are made of fatty acids. So you have a C3 carbons, and you have these fatty acids, low acid number, easy to pre-treat. It's a feedstock of choice in terms of technology. So it's good and nice feedstocks. Around 220 million tons per year available, 20% used for biofuels, mostly biodiesel, but now growing for renewable diesel. Second generation is what we call waste oils and fats, tallow or animal fat in Europe, used cooking oil, pommet oil, so palm oil, mill effluent oil, crude tall oil, which is a residue from a kraft pulp process, distillers corn oil in the US, which is a byproduct of ethanol production from corn, and so forth. So here you have all these kind of waste oil feedstocks. Most of them consists of free fatty acids, still some triglycerides, and then for crude tall oil, it's a different chemistry, some resin neutrals, so some ring structures. But here, increasing acid number, increased amount of contaminants. Yeah, it's not the nicest feedstocks, but it's not rocket science. You have solutions, but here we increase the complexity. And here the third generation is basically what is not first and second. So here we divide the third generation in different categories. So we have, in Europe, it's quite big. So it's called Annex 9 feedstock. So it's EU language, but basically solid waste feedstock. And here EU wants to make fuels out of it, marine fuels and aviation fuel. So we talk about municipal solid waste. We talk about, forestry residue, agricultural residue. And here you need to make a liquid or gas out of it. And here it's a lot of this available, but it's not a liquid, so it's maybe not super relevant for today's discussion. But what you can do and what we start seeing is you can make pyrolysis of it. And here you make a biocrude, and here the chemistry is very complex, the acidity is very high, so it's a nice, good challenges for the chemical engineer I am, but it's quite a complex feedstocks. Then you also have what we call novel crops, rotational crops, so camelina, carinata, jatropha in more tropical regions, and here those feedstocks start appearing. We have a client in North America who start to process the first batch of camelina to make SAF. So it's low acid number, but maybe some longer carbon chains, but it's not that complex. It's more similar to the first generation feedstocks. And then last but not least, maybe not so big in the US yet, it's what we call the recycled carbon feedstock. So here you take a plastic waste, you make pyrolysis, and you can make fuels out of it, so-called recycled carbon fuels. And here it's a lot of contaminants, can be very high acid or some acidity as well, chloride, silicon, halogens, different chemistry, and also so different challenges. What is used mostly, it's plastic to plastic. It's not so much plastic to fuels, but that could come as a new feedstock for refineries. Our goal is to be ready for all this type of feedstock for our clients.
Yeah, I think it's an excellent point. We're looking at these ways to reduce our, carbon footprint on the planet, and that's, instead of just getting rid of these plastics and wastes and trying to repurpose them into other things. So it's an interesting conversation. And one of the words that Sylvain kept using was the word complex. And that's exactly what it is. This is a very complex discussion. It's not, not that taking crude oil, making it into, diesel or, aviation fuel is not complex, but when you're starting to add these different feedstocks that have never been thought before, I'm going to take some food product or a waste stream of some kind and try to turn it into a more usable, renewable diesel or sustainable aviation fuel. I think it's a very novel idea to do that, and to be able to go from A to B is not as simple as it sounds, and it's not. And I'm not an engineer by trade, so I'm just speaking from just listening to Sylvain and Surajit and everyone in the industry that I've talked to, talk about going through that process. It definitely poses a lot of challenges and risks, and so it's important that we all kind of are able to understand this better. And so it's, as much as I'm partaking in this conversation, I'm also learning and taking away from it as well. And I hope the people viewing it are also learning something from it. So yeah, Suraj, I don't know if you had anything to add on some of that.
The only thing I want to add is it's a cost-benefit scenario typically to look at. Most of the owners or the engineers who are designing the processes and plants, they are looking for information of why and what's going to save or cover in a longer period, 40-year life cycle asset. And this is basically an attempt to educate and make aware the industry of the scenarios, the potential disaster that they could face. Now, I won't use the word could, I'll actually use the word they will face, because we have seen very rapid failures where the underside of the roof and rafters were not lined. And in 6 months, those underside of the roof and rafters of a fixed roof tank, the wells and those supports started to rust and fail. So we have a situation where a tank was open for inspection and supposed to be down for a week, was down for 2.5 months because they had to get a crew in with scaffolds up and trying to re-weld plates and then blast and then paint. The whole thing happened was just because of a very simple scenario where we were talking before about if you clean the feedstock, if you take the chlorides out, the acids out, it's much more clean feedstock and it's easy to operate. The other thing I'd like to mention is you can even nitrogen blanket. If you nitrogen blanket, you take out a lot of issues, but the challenge there is if your site run out of nitrogen or the compressor is not working. And let's talk about operational issues in plants and production sites. There are lots of challenges there. And you don't have any nitrogen for blanketing for weeks and months now. And can you think about the acid attack on those wells in condensation? Talking about a lot of places in the US where you have temperature swing anything from 100, 110 F, which is 40, 45 degrees C, hitting down to about 70s to 80s, which is around 27 to 30 C. It's a huge temperature swing, sunset to sunrise. Condensation you're going to get is huge. Living in Houston, and I can tell you what we face. So there's a lot of challenges there, and it's most important to understand because what is the capex side of it, there's also an opex side of it. Both are very important for any site, any design, any owner running these units. Because what the last thing you want is a leakage on a tank or a vessel. And then you have EPA or other authorities on your site and to shut the plant down. We don't want that. Definitely not. I'm sure Europe got guidelines also similar, and we have to just be careful on how we handle projects.
Sylvain, earlier you talked about plastics as a feedstock. Let me ask you this: where does Topsoe see the next generation of unconventional feedstocks coming from?
All of this is very regulation driven. So alternative fuel will always be more expensive than fossil fuels. So it basically you have to see what are the regulations saying in different parts of the world. So EU is going for waste to fuels and solid waste to fuel. That's really what they're promoting. So it's, as I mentioned, this Annex 9 feedstocks, municipal solid waste, forestry residue, ag residue, sewage sludge, and yeah, they want to make fuels out of it for aviation and marine. So here it would require two technologies, gasification. Then the other one would be liquefaction. It could be pyrolysis. So this is a kind of feedstock EU wants to promote. I mentioned plastic, and it could be possible. So you make parodies of plastic. It's possible technically. It looks very much like crude oil, so it's easy to upgrade. We have 2 plants starting soon for plastic to plastic. So, but regulators are not really pushing for that globally. So I think what we foresee that will deploy within the next years is these alternative crops, Camelina carinata, and it's very similar to soybean oil and so forth. So this edible oil. So here it won't be a big challenge, but that would help debottleneck the feedstock supply. So that's what the kind of feedstock we are preparing. But again, all of this is regulation driven. So it depends what the regulators are choosing. And often this climate renewable fuels policy are actually industry policy. What kind of, are we supporting the farmers? Are we supporting the industry? What kind of waste do we have? Like the UK, for example, wants to go for municipal solid waste to SAF. They said we're importing 50% of what we eat already. Yeah. So let's use our waste. So that's really more industry and national policy. The US, like in Europe or Latin America, they want to support the farmers. So it's a lot of corn, ethanol, soybean oil. So it's really climate policy are often not only climate policies.
Yeah, I think that's really good to understand what's happening in the other parts of the world, because here in the United States, we might be using one set of feedstocks or a blend of feedstocks and not considering what else, we might be able to use, and seeing what other regulations are happening in Europe or, Asia or other parts of the world, to then maybe consider that those might be coming, or we might find a new use for some of the feedstocks that we're not using. So I think that's a good point to understand, just from an educational standpoint, to say, like, can we be using, different waste streams, whether that's plastics or, food waste, human waste, things like that, to then take those solids and turn them into usable, biofuel type, scenario. So I think that's important to understand what's happening, everywhere in the world to help us.
Just a couple of points. Bob and I have engaged for about 6-8 months with certain agencies here in North America, trying to learn about how they are working, how they are, the regulations are driven, and what they're using that for. And we're learning new things to some of the very exotic type of things they're looking at that I and Bob would never thought would be coming in. But they're looking at in a 5-year, 10-year cycle where there'll be stricter regulations on using of, say, corn, soy, as a feedstock. And then also SAF is a huge market right now that's happening. And there are better guidelines on SAF right now than was 5 years ago. And wood chips, that type of material to get into SAF and sometimes even into ethanol. We are looking at those projects coming up in a planning stage, in a feed stage, where Haldor and some other folks are also providing technologies. So Bob and I, we are in the front end talking to engineers, and they're saying, "What's the solution? What do you want to do here?" And it's quite interesting. But also, other side is learning about what's coming next. What's in 5 years' time? What's in 10 years' time? Because regulations is going to get tighter, and there'll be more or better grants available if you use certain materials that not affecting farmers or our normal feedstock that goes into veg oil. So the market is really very interesting and very innovative, and so much knowledge there to learn for ourselves too.
Yeah, and Jim, if you don't mind, I'd like to add to what Surajit and Sylvain said there. Like Surajit's mentioning, we're talking to some of these agencies and learning about the different ways that they're using these feedstocks. And Sylvain mentioned liquefaction and pyrolysis and gasification, and we're trying to understand how those are being used and trying to look at those processes. And there's a lot of different temperatures when you do each of those, and so each of those may pose a different challenge. And so whether they're using carbon steel or Surajit mentioned maybe some corrosion resistant alloys that are being looked at, we have to understand, do we need to help protect those as well, from a high temperature cycling, when they're putting these processes in place. So it's a definitely an education, not only on the feedstocks but also on the processes and how they're used, how these plants are configured, and yeah, it's a really interesting conversation just all around the board. So yeah, it's really important that we just try to educate ourselves as much as possible, get involved early on in these discussions, and just try to fully understand. Because just when you think you have something figured out, something new shows up, or some new blend or process comes on board, and we're all just trying to make sure we're fully educated.
So, Roger, you had used the word technology, and luckily we have a technology innovation company with us today. It's Sylvain from Topso. Sylvain, could you talk a little bit about Topso's Hydroflex and G to L biofuels processes?
Sure. So I'll start with Hydroflex. So Hydroflex is basically a hydroprocessing solution. So let's say you have a refinery, you have a hydrocracker or a diesel hydrotreater, you don't know what to do with it. You see there's a big demand of renewable diesel in California, or you want to make SAF for, I don't know, British Columbia, or you name it. You said, okay, a lot of incentives. So how do we do that? So basically, you can revamp your unit using our technology. And instead of, the enemy used to be sulfur and nitrogen in the traditional refinery, and here's basically oxygen and contaminants. So you want to make the same molecules, but you need to target different chemistry. So it's always, it's all about chemistry at the end of the day. And then we have, I think, today 16 references running, so producing a renewable diesel and SAF, a lot in the US, but also in Europe. And I think we have 56 licenses all in all. And we have 6-7 plants starting this year or more. I can't recall. And here's the main target is producing renewable diesel or sustainable aviation fuel. So just for our listeners, if they don't know, SAF, sustainable aviation fuel, is not one thing. It's 8 plus 3. So you have 8 pathways that you can make in a standalone plant, like HEFA is one of them, how to process esters and fatty acids, which is what we do. But it could be alcohol to jet. We talked about alcohol before. It could be fish or drops. It could be, it's 8 different pathways. And then you have 3 different pathways with co-processing, where I can co-process, say, 5% of fish or drop wax, 5% of used cooking oil, and so forth. So this SAF is not one thing, SAF is many things. That was the story in the story. So basically, Hydroflex is what we do. You can also build a grassroots plant. I think 50% of our license are grassroots, and then 50% are revamps, give or take. So that's what we do. And then G2L is gas to liquid. So here we talk about biomass that you might need to gasify. So you make a gas, and here the idea is to make a syngas, synthetic gas, so CO hydrogen. Then from that, you do Fischer traps. So you make your alkanes, and then you can crack to make the product you want. And here we also have a technology. So syn fuels have been known for a long time. If you take countries like South Africa, they have been producing syn fuels for many years, but it's from fossil feedstocks. Here the idea is to make it from biogenic feedstock, and you have a few projects starting in the US. Actually, you have some plants working on it, and everybody's crossing their finger for gasification to work, and then we can take it from there. So we don't do gasification ourselves. Basically, you have to clean the gas, and then we take it from there. So there's no commercial plant now, to my knowledge, doing gasification of biogenic mass to produce fuels, but it will deploy. Like in Europe, there's a big demand for that. As I mentioned, the UK, the whole SAF policy will be municipal solid waste to SAF, and also in the US, a few projects, and Canada.
Yeah, Jim, I'd like to add one thing to what Sylvain mentioned about existing plants versus new plants. And I think that's an excellent point, is when you're building something from scratch, you have an opportunity to do different designs, at least from our standpoint, on making coating and lining recommendations, because you have no other frame of reference in that plant and how it's been protected. But when you have a facility that's existing and they're used to having certain types of steel and linings and coatings that are put in there. And now when you're having to retrofit that to now produce renewable diesel or sustainable aviation fuel, and you're adding, maybe a technology like Topso's, that's where we kind of come into the conversation as well to better understand, are you retrofitting it with similar type, metals? Are you using different metals? And do we have to talk about a different way to add on to that and be part of that conversation? So it's an interesting concept of retrofitting versus starting from scratch, where it might be a little bit not easier, but a little bit more of a streamlined conversation, because everything's coming in brand new versus trying to add to existing.
Bob, you had really kind of keyed off something. You were talking about the collaboration that needs to happen. You have an innovative technology manufacturer in Topso, AkzoNobel International. Our approach when it comes to coating solutions, linings, whatever it might be, is a fit to purpose based on what the project might be. If it's a new build, but in North America, when it comes to these biofuels, our experience is retrofit. It's really kind of taking what's existing and converting it over from traditional feedstock, be it crude, and now going into these into biofuels and feedstocks. Let's open up and talk now a little bit more about when it comes to what do we need to know to really offer a fit to purpose lining or coating solution when we're talking about biofuels. Bob, Surajit, whoever would want to kick it off, feel free to go ahead and start.
Sure. Yeah, I can kind of start, and then Saraji can join in. Yeah, when we have these conversations, like Sylvain mentioned earlier with the different feedstocks, it's important to understand what is that feedstock and what is that chemical composition. So, does it have a TAN number, a total acid content number? Does it have a free fatty acid, percentage that we have to look at? What are the temperatures that we have to consider during storage and loading and offloading? What is the ultimate water content of that, and that's important. And then, does it have any other mineral acids or any other types of, I guess, subset characteristics that we have to understand. And so when we gather that information, I'll take that information to Surajit, who is our linings subject matter expert internally, and feed that information to him, and we have a discussion, and then we may have to come back to folks like Topso and fully understand the different levels of that process and how it has to happen to get to there. So when we get those basic information, sounds basic, but that initial front end basic information, that kind of starts the whole discussion. And then from there, we take a look at the products and solutions that we have to offer and start to form a matrix and start to eliminate what our offering can be and narrow it down to a few potential products based on whether it's an existing tank or whether it's a brand new tank, and in those types of things. So it's a combination of early on discussions with all the different people that are involved, and then like I said, talking to experts like Sylvain and Surajit, and trying to get that information. So Surajit, I don't know if you wanted to try to add to that.
Okay, so no, Bob makes a couple of very interesting points here, and I'd like to add two more to this. A lot of the work that we do is based on testing, and more testing. My intervention into this market happened a long time ago, 2008, 2009, in that period when Malaysia, Indonesia were pretty high in palm oil. Because if you ever try to land into Jakarta airport, you see miles and miles of palm oil plantation on both sides as you land in that airport strip. So palm has been very active in that part of the world, and that's where I tested about 8 or 9 different variants of palm fatty acid, palm kernel oil. So there's a lot of testing that I did back in 2007, 2009 in that period, up to 200F, just to see what the limits. And that is from a protective coating kind of a market. But if you look at our marine team, they have been hauling this type of material 10, 15, 20 years before that. So I would say in 90s onwards, we have a lot of experience both in marine segment and in the protective coating segment, where we tested a lot of our systems, whether what's a fit for purpose, how far can you stretch it. So those are very important data points when we go and talk to engineers or owners and we want to recommend a liner. Haldor is very helpful to us in terms of understanding the limitations in many cases. Now, Bob mentioned one thing about the conversions that we do. We have done a lot of those in the beginning years. Now we're seeing a lot of new projects, but the conversions were difficult in the sense that they were old crude tanks. Some are 40, 60-year-old tanks. So you can imagine the amount of pitting on the floor, but the floor's still good. And also, we have solutions for that. That's not a problem. But other thing was a mindset that Bob mentioned earlier, that most of the owners felt, hey, I've been hauling crude oil for decades. And why do I need to line the entire tank, including roof and rafters? So it was a challenge initially, I would say, to talk to the owners and show them the data, explain the chemistry and the aggressiveness of some of these commodities and why we need to do what we need to do. So it's been a learning ride for us also, I would say, over the process. But it's been a very interesting, sometimes challenging, sometimes very appreciable from the owners who actually understood what we're talking about. So it's been great so far. And thank you, Haldor, also for educating and understanding, working with us those initial days, because otherwise we'd be struggling to fill in the gaps. And that help was much appreciated. One thing I'd like to add finally, saying the catalyst use. If the acid number is changing, going higher, a lot more catalysts need to be used up, and catalyst is not cheap. It's very pricey. So that is something we understood very early days, thanks to Haldor, and we did more and more testing to understand what's going on here. And that really opened our eyes in many cases. Thank you, Jim.
This has been a really outstanding conversation on this topic. And I think the final thing to say is that we really, all of us, encourage discussions with all parties in the contract chain, especially with technology providers like Topso and also with AkzoNobel International, because we really need to understand, how to specify the appropriate fit-to-purpose solution, be it a tank lining or a coating solution, especially when it comes to all the critical assets out there and technology as well. Sylvain, Topso, you have a podcast. It's been running for a number of years. If you could do a favor, if you could talk a little bit about the podcast, and then how can people follow or subscribe to it as well?
Cool. Of course. Thank you. But I'd like also to thank Suraj for his kind words about Topso and collaboration. And actually, this recording or the podcast or whatever we do, it's really about knowledge sharing. The industry is changing. We need to learn what the people before us and after us are doing. We need to expand. We need to talk to everybody. And this podcast you are referring to, called the Fuel for Thought podcast, which is available on all the podcast platform, on our website as well. So on topso.com, you check podcast, or Spotify or whatever, Apple, and I need to name all of them now. But basically, I think we're finishing season 5 now, and we talk about pretreatment, we talk about feedstock, we talk about sustainability, we talk about hydroprocessing, hydrogen, methanol, ammonia. We mentioned marine, so also the marine world is starting to move away, or at least they have to decrease their carbon intensity. So all of this, all the fuel transition and how we're doing, and we're trying to cover the whole, segment. If you have any wish for new topics, I'm preparing season 6 now, so feel free to send us an email. But the new feedstock is always a very interesting topic. So we never address corrosion, but maybe in season 6 we'll talk about corrosion. Why not?
That would be great. And please, everyone who's watching this, check out that podcast, because 5 seasons, it's a lot of very enlightening, informative information, really kind of expand above and beyond this discussion we had on this episode. So again, thank you, Sylvain. Thank you to you and Topso. Surajit, thank you. Bob, Bernard, thank you very much as well.
Yeah, thanks, Jim.
Okay, everybody, this wraps up this episode. So please, if you could do a favor, make sure thank you, Surajit. Make sure that you do like and share this episode with anyone who will be able to gain some knowledge and understanding, but also to feel free to post some comments onto it. And I look forward to the next opportunity on an all new International Innovations Vodcast. Thank you, everybody. Thank you for watching the second part on the topic of biofuels. If you'd like to get additional information on AkzoNobel International products and solutions, just go to international-pc.com. I really look forward to the next episode. Thank you so very much.